All right, for this set of notes, we're going to be talking about heat engines. This is less applicable to questions, but more just for conceptual stuff. So if you do get a question on this, it's not going to be very mathematical, but it'll just be asking you about the process. And it has to do with both the second and third laws of thermodynamics. So when we talk about heat engines, basically it's just something that mechanical energy can be made from by using heat flowing from high to low temperature. So we've already established heat likes to flow from high to low temperature. A heat engine is basically just a way to trick that temperature change, the heat exchange there, to be turned some of it into useful mechanical energy. So what you have, here's a little diagram of it. If you have a high temperature source and a low temperature source, this thing in the middle is going to be your heat engine. And what it does is it takes the amount of heat you start off with and is going to give you a lower amount of heat later on by taking some of it out and making it into mechanical work. So what we see is this over here, where the heat you start with is equal to the heat you finish with plus the work that you get out of it. So the higher work you get out of it, the better your machine is and the less waste heat you have left over. Most engines flow in a Carnot cycle, which we've talked about before. So your delta U is equal to 0. An example of one would be a steam engine. So in this case, we've got water. And again, this is exactly the same, even if you're like, bro, we don't use steam engines anymore. Actually, every single source of power we use, except for, I think, wind and solar, uses a steam engine. Because anything with fossil fuels, with nuclear, all we're doing is heating up water and making it spin a turbine. In the other case, with windmills, the wind is spinning the turbine, so it's a little less efficient than water steam. And then with solar, that's an entirely different story. But same idea here. We've got water being heated up by steam. This is going to be our higher temperature. This is where we're getting our QH from. What's going to happen over here is that this hot water is going to come down here, and it's going to, while it's intaking, expand, heat up the air, and then go into this piston, which is going to push it away, which will spin a wheel, which that's where you're getting your power from. If you hook up magnets to it, you can get an electric charge from it. Then after it comes back down, the piston goes all the way around, comes back, pushes this back in. Exhaust, this closes when it is expanding, but as it is compressing, it opens back up to let some out, where it goes to a condenser. This is just a chamber where the temperature is allowed to cool back down. Then a pump is going to be used to push the water back up, and then the process is going to be recycled here over and over. So QH, that's your heated water, and then it's generating electricity over here for your mechanical output. Whether or not it's hooked up to a generator is up to you. If it is, that's where you get the electricity from. That's all you need to know on heat engines. Again, questions on this are going to be very conceptual, a lot less quantitative with any calculations. But that's it for these notes.